So in this class, we are going to continue on our trigonometric ratios, considering working with the quadrants, as we noticed that quadrants are important as previously stated. If you consider the part of our quadrants, have that explanation, which we had about the signs that are in the four in all the four quadrants that we are given. So in this case, actually, we had the quadrants, which is fine. But in these quadrants, we are going to notice something special, that in each and every quadrant, there is an acute angle, which is referred to as the reference angle, that lies in each and every quadrant has its own. Each in the first quadrant, the reference angle will be taken like this to the horizontal axis. So your reference angle, let's call this alpha for now, in the first quadrant. And the second quadrant, also the same thing. You're going to have your triangle this way. That is how it's going to end up like. And the reference angle is this angle, which is our alpha. This is your reference angle. If you consider in the third quadrant, this is what you're going to have in the third quadrant. And this is our reference angle. The fourth quadrant as well, this is what you're going to have. And this is what you consider as your reference angle. This is from each quadrant. So looking into this reference angle, like I said, we're going to call it alpha for now. It is an angle that is less than 90 degrees. It's an acute angle, this angle. It cannot be equal to 90 degrees. It's in within this. Look where it is. It's in within. It's an angle in within the 90 degrees. Yes, because of other calculations that are exactly at 90 degrees, it can happen. But this reference angle is supposed to be less than 90 degrees. So defining this reference angle, we can say it is involved. It is actually the angle that is called an acute angle, which is between 0 and 90 degrees. So the principle of the inverses is also involved in determining the reference angle. Okay? Principle of the inverse, remember when we talk of the arc, this arc sine of 0.5, this and that. When I talk about that, okay? But this reference angle is always an acute angle. So you can have that as a statement. The reference angle, RA in short. Okay, let me just write in full. The reference angle is always positive. If it is always positive, that means our reference angle is an acute angle, is always positive and acute. And acute. They were not supposed to leave this part of acute. The acute is not, we're not supposed to leave that. And acute angled. Okay? So meaning to say, we are simply saying it's an acute angle, which is positive. So therefore, the reference angle that we are stating is an angle that is greater than 0 degrees, but less than 90 degrees. It must be bigger than, but less than 90 degrees. So meaning to say, the actual angle will be related from now the reference angle. We're going to talk about that. For now, I just need the reference angle. Then we'll talk about determining the actual angle from the reference angle. It's an acute angle. So when calculating I want you to note this. When calculating the reference angle, use positive values. Use positive values. Use positive values. That is when finding or determining the inverse. Use positive values when finding. What are we finding? The inverse part. When finding the inverses. The inverses, you're talking of arc cos of a certain number, arctan of a certain number, arcsine of a certain number. In order for you to have a reference angle, you use what? Positive values, meaning to say, ignore the negative. You must ignore the negative. When a negative is given, ignore it. Ignore it. Wherever there's a negative, ignore for a reference angle. So in short, what does it mean? It means that a reference angle, if we are given, let's say, you want to calculate something, you want to find a reference angle. You want to find the reference angle, only the reference angle, only the reference angle. And you are given something like this. Sine of x is equal to what? We just need what? To find the reference angle. So the reference angle being alpha, or you can call whatever that, you can even write it as reference angle like that. This is the one that we are referring as arcsine of what you are given there. So the reference angle is going to be arcsine of what we are given there, which is arcsine 1. If there was a negative there, you are going to ignore that negative. You are going to ignore that. So for this sign, the one that I'm using here, you're not going to understand because of a 1 that we are using there, because 1 will give us straight 90 degrees. It's a special case that happens on sine, cos, tan. There are some values which give us direct answers. So this one is not going to give us the exact part, but I want us to consider the inverses. So it's arc shift sine, arc sine there on top, arc sine there. Shift sine 1. That was going to give us 90 degrees. Okay, so there we cannot see the effect of it. Let's say it was sine x is equal to 0,5, and we just need the reference angle. It was going to be arcsine 0,5, so that we can properly see the effect of the acute angle. Arcsine 0,5, which is what? 30 degrees. Angle, which is, and this is positive. So it's going to be like that. So in this case, because of a 90, this one is a special case, guys. We cannot put this into the reference angle concept. It just happened that it's a 90 degrees because in our definition of the reference angle, we're saying it's less than 90 degrees. So it can happen like when it is at 90 like that. Even at cos x, which is equal to 0, it gives you that 90 degrees. It's a special, we're going to talk about that on special cases. Okay, there are special cases that we're going to have as a class. But for now, I just need us to understand like basic numbers, like maybe you are given cos x is equal to minus 0,5. And you just want to consider the reference angle. What is your reference angle? The reference angle is going to be arc cos. You ignore the negative. So it's arc cos of 0,5. What is arc cos of 0,5? That is your reference angle. So this is what you're going to have here on our calculator. Arc cos, that is shift cos 0.5 like this, which is going to give us 60 degrees in degrees. Your calculator is in degrees. So you have the reference angle. You ignore the negative. Whether it's a decimal that is given there, whether it's a decimal of this nature, it's a square root, it's what? The reference, you just ignore that, find a cos of what you're given. You've got your reference angle. So in the same sense, they can give us the part where we need the reciprocal. They gave us something like maybe cot x is equal to the square root of 3, and you need the reference angle. We do not have on our calculator, if you check, we do not have cot. So we cannot access arc cot. Where can we access it if we do not have the cot? So we need now to rewrite this in a format that is accessible on our calculator. Our calculator knows sine, tan, and cos. This is what our calculator knows. So how can we write this in any of these three? Is the tan either a sine, a cos, or a tan? Remember cot from the reciprocal of what? A tan. This was taken from 1 over a tan. 1 over tan x is equal to the square root of 3. So we can find tan rather. Instead of working with the cot, we can find tan. What is the tan? We are now back to our equation. Let's cross multiply to find tan. Cross multiply. That's going to be square root of 3 times tan x, which is square root of 3. Tan of x is equal to what? 1 times 1, that's 1. So you divide by square root of 3, square root of 3. So meaning to say the tan of x is now the one that you are having there. 1 over the square root of 3. This is the one now where you find the reference angle. Because tan is known on our calculator. So the reference angle, arctan of 1 over square root of 3, it's already positive, this one. There's no need for us to change anything. So that was going to give us a reference angle. And if you check your calculator, that answer will be positive and also an acute angle. Always. It's going to be like that. Okay, so that's arctan, shift tan, 1 over the square root of 3. Okay, sorry for that. 1 over the square root of a 3. Okay, so that is what you're going to have, arctan, which is 30 degrees. So our reference angle will be 30 degrees. So someone is asking, so you're actually asking yourself to say, why are we considering this reference angle? Why are you talking of the reference angle? Why are you talking of the positive angle? Why are you talking of the reference angle, actually? And also, where the negative angles are, why are we ignoring these negative signs? Because we could have, if you use that cos negative, it was going to give you an angle 120 degrees, this and that. Why are we ignoring this negative? Why are we even finding these reference angles? In conclusion, these reference angles can be used in solving of equations, in determining the actual angle. So what does it mean? From the reference angle, we are going to determine the actual angle. And the actual angle can be positive, can be negative. So in this class, when I talk of the positive angles, each of the negative angles, we're going to see it, which is not a major part. So the major part of our info, we're going to consider the positive angles from reference angles. So that is the reference angle, which is our RA, can be used to determine the actual angle. To determine the actual angle. This is what? Depending with the quadrant now. Depending with the quadrant. Depending with the quadrant. So when I'm saying depending with the quadrant, I'm saying like in which quadrant does that angle lies? The trick that you're giving, where does it lie? Where is it found? Remember your quadrants. Then you determine the exact angle from there. So like I said, considering positive angles, if we are to consider positive angles, as we do understand our positive angles, that's 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Positive angles, the one that we take in anti-clockwise direction. Anti-clockwise. So actually I talked about this before, guys. I'm just going to have a recap there. In the first quadrant, like we saw, this is our reference angle, which is in the first quadrant. This is what we have. Our alpha is there in the first quadrant. And what you need now is the solution, which is the exact angle, which you call theta, or is it x, like the way that is given there. If they write it as sine x, you now say x is the exact angle. If they write it as sine theta, maybe sine x is equal to 0.5, sine theta is equal to 0.5. This one, the angle that is there, this one, is the one that I'm now talking as what? As the actual angle, the exact angle, not the reference angle. So you relate that one from the reference angle that you calculated. So in the first quadrant, remember, theta will be equal to the reference quadrant, to the reference angle. Meaning say theta is equal to what? Theta is equal to alpha. If your reference angle is alpha, theta is equal to alpha. If it was x, you're saying x is equal to x is the actual angle. In the second quadrant, it's going to be like this. Remember, your second quadrant, this is where you have our alpha. The angle is going to be taken here up to this one. This is where our angle is. So theta being the exact angle will be 180 degrees minus this alpha. You're going to remove that. So it will be 180 degrees minus alpha, where alpha is the reference angle. Alpha is the reference angle. Where alpha is the reference angle. In the fourth quadrant, in the third quadrant, I mean this one, gonna have this in the fourth quadrant. This is where our alpha is. The angle theta from the positive horizontal axis. I talked about that. From the positive horizontal axis going like this, up to this one. Meaning to say 180 is involved. So you have to add alpha. Alpha is also taken in. Look, 180 here. Then you get inside 180 plus what? Alpha. Alpha is also involved. So theta was going to be 180 degrees plus alpha. The fourth quadrant, you're going to have it like this. And this is your alpha, the reference angle. So the angle is going to be from the positive. Remember, I'm talking of positive angles in the anti-clockwise direction until we meet this line here. So this theta was going to be out of the 360. We are going to remember, take note, alpha is not involved, your reference angle. So it will be 360 degrees minus alpha, where the alpha is the reference angle. So that is where you need these now, reference angle. You need to know your reference angle. So that is why I was saying, do not use that negative or what is. No. The negative is already removed there. It's already taken out. The negative is already taken out. So it can be used now to determine these actual angles, depending, like we now, and also the interval. That's where we talk of this. So considering positive angles, like I'm stating here, let's say you are being given a simple question that now we need to apply that reference angle now. Okay, let's say you are given to find the solutions. To find the solutions, that is, you are now actually solving an equation. Find the solutions. Let's say this is what you're given. The solution, that is, actually it was like this. Find the solution set, which is for theta. To solve for theta. Like I said, guys, once you're given like this, simply means to solve for theta. If we are given that the sine of theta is equal to 0,5. So if you are given this, we have to find the exact angle theta. Talk about the exact angle theta. So as we can see here, they must give us an interval to say where theta is it taken from, because we can see theta can be in any part where it is positive, like here, where sine is positive. We are talking about what? We are now back to the cast concept. We're talking about which quadrant, where is it positive? So they must tell us the interval to use. And theta must be greater than or equal to 0 degrees, less or equal to 360 degrees, meaning to say we can take any answer as long it is within these 0 to 360 degrees. So how do I find the solution? Okay, this is what we're going to do. The first thing is to determine the reference angle as usual. So you determine the reference angle. So first, you're going to find the reference angle, which is our alpha. So the reference angle is equal to what? Arc sine of what? From here, sine theta is, remember sine theta is what? Sine theta is 0,5. You ignore that theta and as if it's not there. You find it as reference angle, which is what? Arc sine. Arc sine of 0,5. So on your calculator, you are going to use your calculator to determine the arc sine of 0,5. And this was going to give you 30 degrees as a reference angle. As a reference angle. So what will be the exact solution now for theta? So this is what you do. You take now into consideration sine theta is 0,5 here. What is it that you are given there? 0,5. Here it's a positive. Remember I talked about positive angles. I mean about like the quadrants, in which angle the signs in quadrants, the signs. So that's where the signs of the quadrants now plays a role, because this sign is a positive. So in which quadrant where we have sine as a positive, we are now back to the cast. So using our cast concept, it follows that sine is positive. This sign can be positive where? Where sine? All in the first quadrant and in the quadrant for S in the second. We are now considering there now to say sine theta is positive. Sine is positive in the what? In the first and second quadrant. That is where our sine is positive, the first and the second. So therefore, we can find now the exact solution for theta. So therefore, our theta is going to be what? In the first quadrant, theta is equal to what? The reference angle, which is our alpha, no matter the way that you want. So if theta is equal to the reference angle, what is our reference angle? 30 degrees. So theta is going to be equal to 30 degrees. But are we done? No, because we still have another theta again, which is supposed to be taken where sine is positive. In which quadrant again? The second quadrant. Sine is positive. Remember, this is the quadrant for S, sine. And in the second quadrant, theta is taken as what? 180 minus the reference angle. So there, our theta was going to be taken as 180 minus the reference angle, which is 180 degrees minus the reference angle, 30 degrees. And that will give us 150 degrees, just like that. So we've got two possible values of theta in this interval that we are given, 0 to 360. There are two possible values of theta. There are two possible values of theta where sine is positive. So what if this was a cos? Okay, let's consider a cos. It was just going to be the same. If it is to be of a cos in the same interval, Okay, let's just have another question for a cos with the same condition. Okay, let's consider for a cos this time. Cos of theta is equal to 0.5. So the first thing, just like the previous case, is to have the reference angle. What is our reference angle? Arc cos of 0.5. It's already a positive, so just use as it is. Arc cos 0.5, which was going to give us 60 degrees as our reference angle. But to determine theta now, the exact angle that we need there, theta, within this interval, we have to consider, because cos is what? A positive. If we were to answer here, it's a positive. Where is cos positive? In which quadrant do we find cos being positive? In the first, all, and C, the fourth quadrant. So where cos is positive, that is the first, and what? The fourth quadrant that we have to consider, where cos is positive. So our solutions for theta now, according to the quadrants, in the first quadrant, theta is equal to what? The reference angle. And what is our reference angle there? 60 degrees. In the fourth quadrant, where cos is positive, what is our theta now? 360 minus alpha. 360 minus what? The reference angle. So it is theta 360 degrees minus the reference angle. What is our reference angle there? 60 degrees. So theta was going to be 300 degrees. So these are the two possible values of theta from the interval that we are given. So the question is, what if this was now a negative angle? Okay, let's consider another question where you are given a negative value. I mean, not a negative angle, but a negative value. They can give us that. You are given a negative value. What are you going to do? Let's say we are given the tan of theta being equal to -1. Same interval, 0 to 360. How are you going to find the solutions then to solve for theta? As usual, first thing, reference angle. So for the reference angle, remember I said arctan of what? The number that you give, but ignore the negative. There's a negative there. So as long as you have to determine the reference angle, remember what we had here of the reference angle. It's only that I removed that part of the notes, but still remember I said you ignore that. You ignore your negative that you're given. So it's arctan 1. Ignore the negative. So we have to ignore the negative there. So by ignoring the negative, we are just having a 1 there. So the reference angle is not affected by that. We just use as it is a 1, which is going to be 45 degrees on your calculator. Now you conclude in finding of theta. Which quadrant is it? That theta, which quadrant is it? That the tan is what? Negative. As you can see there. Our tan is a negative. The answer for tan is negative. It's a negative value. That answer, it's negative. Where is it that tan is negative? In which quadrant? Where tan is negative. We know that tan is positive where it is presented here in the third. And this one for all. This is where it is supposed to be positive. So meaning to say where we do not have a t, that is where it is negative. We do not have a t where? In the second quadrant. It's for S. So meaning to say there, tan is negative. In the fourth quadrant, it's for cos. So what does it mean about tan? It means tan there is negative. So the quadrants now are the ones that will give us the solution thereafter to say where tan is negative. Tan is negative in the what? In the second and fourth quadrants. That is where it is negative. Where it is negative, that is where we take our solutions for theta, now the exact angle. So theta, exact angle, is given as what? In the second quadrant, where it is negative. In the second quadrant, 180 minus reference angle. Just like that. So you're just going to substitute 180 minus the reference angle, which is 45 degrees. So the theta there was going to be 135 degrees. Same concept. Or the same theta there. But being in the fourth quadrant where tan is also negative, theta was going to be what? 360 minus the reference angle. And we have that. 360 minus the reference angle, 45 degrees. So the difference there is now giving us theta. The exact angle, which was going to be 315 degrees. You now have theta, exact angle. So as a solution set, as the theta values, you're talking about theta being 135 or theta being 315. Where it is a negative, where tan is a negative. These are the values of theta. So you can just write your solution set theta is equal to what? 135 and 315. That's it, just like that. So I need us to actually work with more questions. It can be helpful as you work with the quadrant, like the one that you're given, and also understanding of the reciprocal, the reference angle, ignoring of the negative, this and that. Even on the solutions, they can give us the inverse, where the reciprocal is needed. Let's just have one with the reciprocal. They can give us something like maybe cosec. Theta is equal to 1,095. This is what you have. And what is it that you need from there to solve for theta? But we do not have a condition on our calculator where cosec is there. So we're back now to the inverse, trig. The reciprocal of it, the reciprocal cannot determine this. What is the reciprocal of a cosec? Where was it taken from? We do understand that a cosec of theta was taken from a 1 over sine. So if that is the case, it means where we see this cosec here, we are going to write it as 1 over the sine of theta being equal to what? 1,095. So if 1 over sine of theta, this is the same as like over 1 like this, guys. So if you understand your mathematics very well, if 1 over sine is equal, what about a sine? Just interchange. So what does it mean? It means sine theta is equal to what? You also have to interchange this with sine theta over 1. That is to have sine theta. So 1 over this. What are you having? 1 over 1,09, just like that. Or you can cross multiply this and that, then you divide. I talked about that. So another step. When you have something like a sine, because it's there on your calculator, it knows this sign. It knows this. You can now think of calculating of the reference angle, which is what? Arcsine of this part that you're given, 1 over 1,095. Arcsine of that. We are now talking of the reference angle now. So that is arcsine 1 over 1,095. Just gonna use your calculator direct, which will give us something like 65 957 degrees to put it in small places as our reference angle, not as the theta, the solution. No, the theta, the solution. Now, where are we going to take it from? We can see here sine theta here. From sine theta, what is it that we have? Sine theta is equal to this. And what is it? It's a positive. This value that we see here, it's positive. So where is it that sine is positive? Sine is positive where? The first and the second, where we have S. So we are going to consider the first and the second quadrants for the solutions now. So meaning to say, therefore, our theta, which is the exact angle, second quadrant. Okay, let's start with the first one. The first quadrant, theta is equal to what? The reference angle. So our theta was simply going to be equal to 65,957 degrees. Talking of the same theta, but in the second quadrant now. In the second, 180 minus the reference angle. So that is what you're going to have, which is your reference angle, this one, 180 degrees minus 65.957 degrees. That was going to give us another theta, another value of theta, which was going to be 114,043. Within the interval, these will be the values of theta. Now, as a solution set, you can just write set from this value to this value. So this is the condition of our, the reference angle. So you need to revise much on your reference angles because they can ask you to determine the solution set. For the solution set, you will need the reference angle, and for you to need the reference angle, you're going to need the inverse of this arcsine, arctan of the positive value that you're given there. Then you analyze your final answer with the quadrants always. Your analysis is supposed to be taken from the quadrants. You do not conclude from there to just say, okay, this angle that I just calculated, that is my answer. No. The quadrants are the ones that will determine for you the final answer now. The quadrants will determine that for you. So you need to understand your quadrants in as much as you are revising trigonometry. Try to work on your quadrants in as much as you can.